one point. Whether electron is ejected or not, whether electron is ejected or not from a metal surface does not depend on what? Intensity. Antena? Intensity. Whether electron is ejected or not from a metal surface does not depend on intensity. Experimentally, we observed that until we have better way until a certain frequency of light, electrons are not ejected no matter how large is the intensity. This is one more point. Experimentally, we observed that until a certain frequency of light, electrons are not ejected, no matter how large is the intensity. Next, the minimum frequency of light, the minimum frequency of light required to release photons. Not photons, electrons. The minimum frequency of light required to release electrons from a metal is called threshold frequency. Then what is threshold wavelength? Can you define threshold wavelength? Chappandi. Threshold wavelength. Threshold frequency is minimum frequency. Threshold wavelength and you have to write maximum wavelength. The maximum wavelength of light required to release electrons from metal is called threshold wavelength. Okay, next. Minimum frequency and threshold frequency and threshold wavelength depend on metal or not? Threshold frequency and threshold wavelength, do they depend on metal? So let me write that. Threshold frequency and wavelength of light depends on nature of metal. Next, you need to provide minimum energy to the metal so that electrons are ejected out of the metal. What is that minimum energy? That is called work function of that metal. So let me write here work function of metal. It is denoted by phi. What is this? Minimum energy of a photon. Minimum energy of photon photon ante it's a particle of light, okay, or you can say minimum energy of light photon required to release electrons from metal is called work function of that metal. So can you tell me what is the expression for work function? If this threshold frequency is f naught and this threshold wavelength threshold wavelength is lambda naught, then I can write phi is equal to h into f naught. This is nothing but frequency of the photon, hf naught, or I can also write this as hc by lambda naught. This is work function of the metal. Generally, work function of the metal will be in terms of electron volt, because photons will have energy in terms of electron volt, in units of electron volt. Got it? Next. The photocurrent, the current, you can say photoelectric current, depends on what? Tell me. The photoelectric current depends on frequency or intensity. ఇది మనం చేసాం ఎక్స్పెరిమెంట్ లో. By intensity, not frequency. Certain frequency ki current will be non-zero. Adi correct. In order to make current flow in the tube, you need minimum frequency. That frequency is threshold frequency. I agree with that. But in order to further increase the current, you need to increase the intensity. So the current, photoelectric current, depends on intensity of incident light. Okay. So if you increase the intensity, the current also will increase. If you increase the frequency, the current will not increase. But if you decrease the frequency, at a certain value of frequency, current will become zero. That frequency is called threshold frequency. So you cannot say that current completely is independent of frequency. Current kind of depends on frequency. And frequency is just like a permission for current to flow. Once current starts flowing, it will not depend on frequency anymore. It will depend on intensity. Got it? So make a note of these points. We'll go to the next slide. And Anurag, you raised your hand. You want to speak anything? Raise your hand one more time. Acha, it's already cleared. Clear ayipotadli. Okay, make a note of all this first. Next, what do we discuss? Yes. Ejection of an electron. Ejection of an electron from a metal surface depends on A. Energy of single photon. Energy of a single photon. Total energy of photons. Tell me which option is correct. Option A is correct, undoubtedly. Everyone agree with this? Because energy of a single photon depends on frequency. More frequency, more is the energy of single photon. Whereas the total energy of photons is related to intensity. More number of photons, more is the intensity. Also, total energy of photons depends on energy of each photon also. So you can make one more point here, intensity. What is intensity? Energy per unit area into unit time. This is intensity. This intensity depends on A, energy of each photon, B, total number of photons. This is one more question, Ankunna. Tell me which option is correct, A or B? కొంచెం ఆలోచించండి, కొంచెం ఆలోచించండి. Yes, some are saying both. Very good. Both are correct. ఎందుకంటే what is intensity? Energy per unit area per unit time. Now, total energy also depends on energy of each photon, kada? And it also depends on total number of photons. So intensity is dependent on both number of photons ejected as well as energy of each photon. This is one more question. Next, from here, can you conclude or can you answer one question? Photoelectric effect. Photoelectric effect is explained by wave nature of light, the particle nature of the light. What do you think? Third question. Answer is obviously particle nature. Why not wave nature? Because if you consider wave nature, no particle there, then if you keep on increasing the intensity of light, energy should increase. If you keep on increasing the intensity of light, energy should increase, and that energy should be able to release the electron from the metal. But that is not observed here. If you increase the intensity, electron is not released from the metal. That means wave nature is unable to explain photoelectric effect properly. Particle nature is able to explain, because particle nature talks about energy packets. That energy packet is called photon. Now, photon should have minimum capable energy in order to release the electron. So photoelectric effect is explained by particle nature of light. Next. After incidence of light above threshold frequency, ejection of electrons is spontaneous or instant. Take some time. What do you think? After incidence of light above threshold frequency, ejection of electron is instant, spontaneous. because energy is given instantaneously. Energy is given in terms of packet. Okay, energy is given as a packet. It is not slowly given, gradually given. Okay, it's like taking a tablet. It is not like injection. Injection ante slowly the medicine is given. Whereas tablet ante at a time you take everything. So since energy is taken at a time, photon is also released spontaneously. So after incidence of light above threshold frequency, ejection of electron is instant. If you think regarding wave nature of light, there will be some time lag for ejection of electrons, because wave nature of light ante no matter what is the no matter what is the frequency, if you increase the intensity, then electrons will be ejected according to wave nature of light. That time you keep on increasing the intensity and the electron will slowly keep absorbing the energy. That time, according to the wave nature of light, the ejection of electrons should take some time, but that is not observed in practical. Ejection of electrons is instantaneous. Sriram Satvik is asking, as you said, total energy of photon depends on energy of a single photon. Then ejection of electron should indirectly depend on total energy. Yeah, it will depend on total energy if energy of single photon is greater than work function. If energy of single photon is less than work function and total energy is greater, that time ejection of electron is not possible. You understand this subtle difference. Next, one more question. I read t is equal to t to the power 9 minus 9 seconds. Is it true? Maybe the ejection of electrons is almost instantaneous. 1 nanosecond is almost 0, so maybe you can say time lag is equal to 0. Next, if photoelectric effect was explained by wave nature of light, then electrons are ejected for every frequency. Every frequency of light. B. Electrons are ejected instantaneously. There is a time lag in ejection of electrons. Low intensity light, if intensity becomes very low, electron ejection is not possible. First, read the answer carefully, read the question carefully and give the answer. It is not single option correct, it is multiple option correct. Now tell me the answer. We are not discussing the fact here. We are discussing a hypothesis here. It's not experimental evidence. If photoelectric effect was explained by wave nature of light, that means you see photoelectric effect from the point of view of wave nature, not particle nature. So don't write your experimental conclusions here. So what are correct one? electrons are ejected for every frequency of light. True or not? Because according to wave nature, there is nothing called packet of energy or photon. So every frequency of light can produce sufficient energy. A is correct. Electrons are ejected instantaneously. This is wrong. There is a time lag in ejection of electrons. This is correct. If intensity becomes very low, electron ejection is not possible. Is it true or not? When seen from wave nature of light, it is true. Because if intensity becomes very low, that time energy of the light is becoming very low. That time light cannot provide sufficient energy to release a photon, to release an electron. So D is also correct. This is a question asked from wave nature of light perspective, not particle nature. That is why A, C, D are correct. If it is particle nature, if we are talking about experiment, if you are talking about fact, then only B is correct. A, C, D are wrong. Okay, this is a hypothetical question. So whatever you can see on the screen, please note down. We'll go to the next slide. Note down this question. This is plate A and this is plate B, or 1 and 2 button. This is plate 1 and this is plate 2. Surface area of plate 1 is equal to A, and wavelength of incident photons, incident light, wavelength of incident light is lambda, which is less than lambda naught. What is this lambda naught? It is given that this wavelength of incident light is less than lambda naught. This lambda naught is threshold wavelength. Threshold wavelength. And what do you think? Photoelectric emission is possible or not? Electron emission is possible, obviously. Next, intensity of incident light is equal to I. Intensity of incident light is I, and let me say that I have connected an ammeter here. Okay, current in ammeter. Ammeter is small f. This is current in ammeter. Then what else? That's it. Then which of the following is correct? Which of the following is true? Option A, I by E is equal to IA lambda divided by HC. Option B, I by E is much greater than IA lambda divided by HC. Option C, I by E is much less than IA lambda divided by HC. Option D, I by E is approximately equal to IA lambda by HC. Solve this question. అసలు నేను ఏం అడిగానో ఫస్ట్ అర్థం చేసుకోండి. వాట్ ఈస్ I by E? What is E? First of all, other terms are according to their actual definitions. E is charge on an electron. E is charge on an electron, and A is area already ichana. I is intensity, lambda is wavelength, H is Planck's constant, and C is speed of light. Okay, అది కూడా రాస్తాను ఎందుకన్నా మంచిది. E is charge on electron and H Planck's constant. Then C, speed of light. In vacuum. First, what I asked in the question that you should tell me before giving me the correct answer. What is I by E and what is IA lambda divided by HC? What is this, you tell me? Let me continue. See, most of you are telling what is I by E ante current per unit charge of an electron. And what is there on the right hand side ante intensity per unit energy of photon. Alaga nenu adigindi. Okay, see, what is this basically? Let me take a different color. What is I? I is the intensity. Okay, intensity into area will give me what? Energy per unit time. Okay, divided by Hc by lambda is what? What is Hc by lambda? Energy of each photon. So this will give me number of photons incident on plate per second. Do you agree with this? This expression we have seen in what is that? Radiation pressure also. Do you remember this? First of all, did you understand this? Whatever I'm talking about, IA lambda divided by Hc is what? Number of photons incident on plate per second. And what is I by E? I by E, this is charge flowing per unit time. That is current. I is charge flowing per unit time divided by charge on each electron. This will give me number of electrons flowing per second. Avuna kada? Number of electrons flowing per second. This is not frequency. This is I by E ante I is current. E is charge on each electron. Current is what? Charge by time. So total charge divided by charge on each electron will give me number of electrons. Number of electrons per unit time ante number of electrons flowing per second. Now, did you understand the meaning of these two expressions? Are you following the class, everyone? Okay. Now assume that number of photons incident on plate per second are 1000. Ante 1000 photons are falling onto this plate. What kind of photons are they? They are capable photons. What do you mean by capable photons? Photons that are capable of ejecting the electron. How can you say that they are capable photons? Because it is given that wavelength of that photon is less than the threshold wavelength. Ante every photon is capable. Okay, 1000 capable photons plate మీద పడితే how many electrons are formed? 1000 electrons are formed, or less than 1000 electrons are formed, or greater than 1000 electrons are formed? Can you say that 1000 photons are incident on the plate ante more than 1000 electrons ejecting out of the plate is not possible. Agree or not? Endukante from photoelectric effect, you know that one photon is capable of releasing one electron. Ante 1000 photons padtunte per second, 1000 electrons kante ekkuva bayitiki raalevu kada. So directly second option is wrong. Because what does this say? Number of electrons flowing per second is greater than number of photons incident on the plate per second. This is wrong. Now coming to A, C and D. In fact, option A is also wrong. Option D is also wrong. Option C is correct. Experimentally, it is proved that if 1000 capable photons are incident on the plate, only one to two electrons come out of the plate. Ante the efficiency is 1 to 2%. Not even 1 to 2%, sorry, 0.1%. Ante. How can you explain this? Option C is correct. Intavaraku okay. How can you explain this? Assume that this is the plate surface, and these are the electrons. These are the electrons. Okay. I did not explain why C is correct. I only said C is correct, and I'm explaining right now. Now assume that a photon is hitting any one electron, is hitting this electron. Okay. Now when it hits this electron requires some minimum energy to become free to come out of the surface. What is that minimum energy? That is known as work function. Now this photon is having energy greater than work function. Why? Because photon wavelength is less than threshold wavelength. So this will have greater energy. Now once energy is transferred from photon to this electron, is it necessary that electron should come out like this only? Is this electron having brain? That, oh, okay, I got energy, now I should go out of the surface metal. Ala rule em ledhu kada. This electron can go further inside. This electron can go this side. This electron can go this side. Are you able to understand? When this electron goes further inside, is it possible to come out of the surface? No. If this electron moves this side, it will go and collide with neighboring electron. That time it will again lose energy. Again, if it goes this side, it will go and collide with one more neighboring electron. Again, it will lose energy. Or this electron may collide with nucleus itself. This is the nucleus. That time also it will lose energy. So even if this electron is getting hit by a capable photon, okay, the probability of this electron directly coming out of the surface is less. That is why out of 1000 photons, capable photons, 1 or 2 electrons come out of the surface. Remaining all electrons, they go collide with other particles in the metal and lose energy. By the time they come to the surface of the metal, they will not have sufficient energy to come out of the metal. Only few electrons come out of the metal. That depends on the probability. That is completely depending on the chance. Did you understand this question? Everyone? Only Sriharsh is saying yes. What about remaining people? Understood kada? Sure. Okay then. Yeah, Amog, I'll explain this once again. Don't worry. I'll explain it in the working session. Because time is up. What is time now? It's 11:15 already. We'll continue from here in the working session. And we'll also solve many questions in working session from previous chapters also. And I'll also update your doubt sheet. I'll answer all the questions in your doubt log. Chalo, meet you in the working session. Until then, take care. Bye-bye.